Hello and welcome back to Engineers Olympiad, where learning meets success. We're on to second chapter of surveying, that's theory of errors. We have completed 2 video lectures. They are up on the channel Engineers Olympiad. You can watch those videos before watching this video. This is video lecture number 3. All right, students, so let's begin. Law of weights. Before studying law of weights, we must know what is weight of a quantity. What is the definition of weight? The weight of a quantity is trustworthiness of a quantity. All right. So the trustworthiness of a quantity is its weight. And the weight indicates the relative precision of a quantity within a set of observations. Within a set of observations, the relative precision determines the weight of that particular quantity. So the weight indicates the relative precision of a quantity within a set of observations. All right. The greater the precision of an observation, the greater is its weight. So the greater precision indicates greater or higher weight. And weight of a quantity is its trustworthiness. All right. And this weight is always expressed in some numbers. Always expressed in numbers. And higher number means higher weight. All right. The greater number indicates higher precision and trust as compared to the lower number. Greater number indicates higher precision and trust and hence higher weight. All right, students. So weight of a quantity is its trustworthiness, or it indicates its relative precision within some set of observations. Let's illustrate this with help of an example. For example, a quantity with a weight of 8 is 4 times as precise as a quantity with a weight of 2. If we have some observation with a weight of 8, it is 4 times as precise as an observation with a weight of 2. All right. Now let's study how these weights are allocated. Allocation of weights. All right. These are allocated in a number of ways. Let's study first way. Weights are assigned depending upon the degree of precision, as already discussed. And these weights, these are generally taken inversely proportional to the variance or square of the standard deviation or standard error. Weights are taken inversely proportional to the variance, which is square of the standard error or standard deviation. Let's illustrate this with the help of an example. For example, there is a set A which has a variance of, let's suppose, 171.6. All right. And there is a set B which has variance of 86.5. And how do we allocate weights to them? Weights are taken inversely proportional to the variance. So weight of set A divided by weight of set B is equivalent to 1 by 171.6 divided by, all right, which is all right. And by further calculations, this will come approximately equal to 1 by 2 if we'll take numerator as unity. All right. So let's generalize this rule. W1 by W2 is equal to V2 by V1. The weights are generally taken as inversely proportional to the variance, which is square of the standard deviation or square of the standard error. All right. This is how weights are allocated. Second one. The weights to the quantities measured in similar conditions are assigned in direct proportion to the number of times a quantity is measured. All right. So the weights of the quantities measured in similar conditions are assigned in direct proportion to the number of times we take the observations. For example, let's illustrate this with the help of an example. If one angle A is measured, let's suppose 4 times, all right, and it would have a weight of how much? 4, all right, as compared to another angle B, which is measured only once. All right, let's generalize this thing. W1 by W2 is equal to N1 by N2. All right, so the weight of a quantity measured in similar conditions are assigned weights in direct proportion to the number of times those quantities are measured. All right. Third way. The weights are allocated by personal judgment depending upon the prevailing field and environmental conditions. Prevailing field and environmental conditions. Then a surveyor, by his personal judgment, allocates certain weights to certain measured quantities. All right. For example, the lower weight is generally allocated to the observations made in difficult terrain. The observations which are done in difficult terrain are given less weight. All right. Compared to the observations which are made on a level terrain under stable conditions, they are given as higher weight. All right. So surveyor uses his personal judgment, and depending upon the prevailing field and environmental conditions, the lower weight is generally allocated to the observations which are made in difficult terrain, and we assign higher weight to those observations which are made on a level terrain under stable conditions. And these observations which are assigned lower weight in a difficult terrain, they are taken under varying environmental conditions of temperature, wind, or humidity. All right. This was the third way by which certain quantities are assigned their respective weights. Fourth way. The weight of a level line is generally taken as inversely proportional to the length of the route. All right. The weight of a level line is generally taken as inversely proportional to the length of the route, where L is the length of the route. All right. This was the fourth way. How do we assign weights to different quantities? Moving on. Fifth one. Now there comes law of weights, all right? Allocation of weights is or. Now law of weights. Already written over here. All right. Law of weights. Let's study the first law. The first law of weight is the weight of the arithmetic mean of a number of observations of unit weight is equal to the number of observations. Let me illustrate this with the help of an example. For example, if an angle A is measured 3 times, angle A is measured 3 times and following values are obtained. Let's suppose first one 40 degrees, 30 minutes and 15 seconds, and each observation has a unit weight. This has to be noted. Second value of this angle, this comes equivalent to 40 degrees, 30 minutes and 10 seconds. It also has a weight of unity. And the third observation, we have the measured value of this angle A as 40 degrees, 30 minutes, and let's suppose 20 seconds. All right, this angle A is measured 3 times, and every time we get these readings, and each quantity has a weight equal to unity. Now the sum. This is how much? 45 seconds, 30 minutes, and 121 degrees. All right. And what is the arithmetic mean? This is 121 degrees, 30 minutes, 45 seconds divided by how many readings? And this comes equivalent to 40 degrees, 30 minutes and 15 seconds. All right. These observations each had a weight of unity. Now we have arithmetic mean, and this will have a weight of 3. Sum of all these. So this is the first law of weight, that weight of the arithmetic mean, all right, of a number of observations, each having unit weight, is equivalent to number of observations. All right. So this arithmetic mean will have a weight of 3. This was the first law of weight. Moving on, let's study second one. The second law of weight. The weight of the weight arithmetic mean is equal to the sum of the individual weights. Let's suppose angle A is also measured thrice here, and each time we have reading as, let's suppose first one 40 degree, 30 minutes, 15 seconds. And the third observation is 40 degree, 30 minutes and 7 seconds. But each observed quantity has different weight. The first one has a weight of 3, second one 2, and third one unity. We have to find its weighted arithmetic mean first, and weighted arithmetic mean is found by following equation. Weighted arithmetic mean is equal to 40 degree. First one, we have to multiply them with their respective weights. plus second one plus we have to multiply it by unity divided by 3 plus 2 plus 1. This is how we calculate weighted arithmetic mean for those observations where every observation has a different weight. And by calculations, my weighted arithmetic mean comes equivalent to 40 degrees, 30 minutes, and 12 seconds. All right. Now this will have a weight of sum of the individual weights. That is, it will have a weight of 6. All right. So the second law of weight is that the weight of the weighted arithmetic mean is equal to the sum of the individual weights of the observations. All right, moving on. Third law. The weight of algebraic sum of two or more quantities is equal to the reciprocal of the sum of reciprocals of individual weights. All right, let's illustrate this with help of an example. For example, this is our angle A. It has a value of 40 degrees, 30 minutes, and 20 seconds. And it has a weight of 3. And angle B has a value of, this is equal to how much? Let's suppose it is equal to 30 degrees, 20 minutes, and 10 seconds. And it has a weight of, let's suppose, 2. The first observation, the angle A has a weight of 3 and angle B has a weight of 2. Now, what will be the weight of algebraic sum of these quantities? Weight of A plus B. How much? The law says the weight of algebraic sum of two or more quantities is equal to reciprocal of sum of reciprocals of individual weights. So weight of A plus B will be reciprocal of sum of reciprocals of individual weights. All right. By calculations, it will come equivalent to 6 by 5. So weight of A plus B, weight of angle A plus angle B is equal to 6 by 5. This is our third law of weight, that the weight of algebraic sum of two or more quantities is equal to reciprocal of the sum of the reciprocals of individual weights. Similarly, A minus B will also have a weight of 6 by 5. Algebraic sum or subtraction as well, all right? So both will have weight of 6 by 5, which is equal to reciprocal of the sum of the reciprocals of the individual weights. All right. Our fourth law is if a quantity of a given weight is multiplied by a factor, the weight of the result is obtained by dividing its given weight by the square of that factor. Let's illustrate it with the help of an example. For example, we have an angle A, whose value is 40 degree, 30 minutes and 20 seconds. All right, we have angle A, whose value is equivalent to 40 degrees, 30 minutes and 20 seconds and has a weight of 6. How much? Its weight is 6. Now, if we'll multiply it by a factor, let's suppose 2. So the weight of 2A will be equal to, what does the law say? If a quantity of a given weight is multiplied by a factor, the weight of the result is obtained by dividing its given weight by the square of that factor. So 2A will have value of, all right, we have to divide the weight by the square of that factor, which will come equivalent to, all right, so weight of 2A will be equal to 3 by 2. Moving on. Law number 5. If a quantity of a given weight is divided by a factor, the weight of the result is obtained by multiplying its given weight by the square of that factor. All right, let's illustrate this with help of an example. For example, we have angle A, whose value is equal to, same, 40 degree, 30 seconds and 20 minutes and has a weight of 6. And if the quantity is divided by a factor, let's suppose 2, weight of A by 2 is equal to, what does the law say? If a quantity of a given weight is divided by a factor, the weight of the result is obtained by multiplying its given weight by the square of that factor. Which will come equivalent to 24. So weight of A by 2 will be 24. All right, this was, so our angle A by 2, how much? 20 degrees, 15 minutes and 10 seconds. Will have a weight of 24. This was our 5th law of weight. Moving on. All right. If an equation is multiplied by its own weight, the weight of the resulting equation is equal to the reciprocal of the weight of that equation. All right. For example, if A plus B is an equation and whose value is equal to 85 degrees, 20 minutes and 20 seconds. All right. We have an equation A plus B and whose value is 85 degree, 20 minutes and 20 seconds and it has a weight of 2. Now, if we'll multiply this equation by its own weight, twice A plus B, all right, what will be its weight? What does the law say? If an equation is multiplied by its own weight, the weight of the resulting equation is equal to the reciprocal of the weight of that equation. All right, so this will have a weight of 1 by 2. All right, so 170 degree, 40 minutes and 40 seconds. Will have a weight of how much? 1 by 2. So the law says if an equation is multiplied by its own weight, the weight of the resulting equation is equal to the reciprocal of the weight of that equation. All right, moving on. Number 7. The weight of an equation remains unchanged if all the signs of the equation are changed. All right, for example, we have an equation a plus b, and whose value is equal to, let's suppose 79 degree, 20 minutes and 10 seconds. 79 degree, 20 minutes and 10 seconds. All right, and it has a weight of, let's suppose 3. And if we change the signs of the equation, that is, this will have weight, same weight. It won't be changed. So the law says the weight of an equation remains unchanged if all the signs of the equation are changed. Will also have a weight of 3. This was the 7th law. Now the last one. The weight of an equation remains unchanged if the equation is added to or subtracted from a constant. All right. For example, this is our equation a plus b, whose value is equal to, all right, and this has a weight of 3. Now there is another equation, for example, all right, this will also have a weight of 3. So 100 degree, 39 minutes and 50 seconds. 100 degree, 39 minutes and 50 seconds will also have a weight of 3. Similarly, if we'll take another equation, all right, so this is how much? 259 degrees, 20 minutes and 10 seconds. This will also have a weight of 3. So the last law of weight suggests that the weight of an equation remains unchanged if the equation is added to or subtracted from a constant. All right, so this was about the law of weights. All right, with this we conclude today's video lecture. I hope it was informative and thank you for watching.